a practical guide to testing observables. I came up with the idea for this talk just because also in real life project, I stumbled across the fact that testing RxJS is pretty hard and often very intimidating. It feels really like having a big hurdle that you somehow need to overcome, but it's quite challenging to get in the right mindset. And what I want for this talk to show you is how to write maintainable tests in a very effective manner. And on top of that, I also want to show you how to do that without marble diagrams. But my opinion on marble diagrams and much more about that later on. Before we dive deep into that, my name is Jan-Niklas Wortmann. I'm a consultant for Evora IT. I'm a member of the RxJS core team and also in Angular GDE. So let's get right into it before we lose some time. Here we have a very easy example for some RxJS code, right? We're using the creation operator of to create an observable that synchronously emits some value, in our case, a Boolean value that is passed to that very function. How would a test for that look like? How would a marble diagram, first of all, look like? Exactly like that. So we have the of operator, and it creates an emission of true that emits synchronously and then completes. The test for that looks quite simple. We are subscribing to the observable, and then we are expecting a certain value to be emitted. So far, so good. Seems to work. Our test is passing. Everything's fine. What I like to do in situations like that is actually to also do the negative test to see that my test is properly working. So for that, we're just replacing our expectation with false here. And now what we would assume is that the test is failing, right? Well, apparently not. And this is when things start to get a little bit crazy with RxJS and testing. So how can that be? The thing with expectations in testing is that if you have an unmatched expectation, it throws an error. And if you have an unhandled error inside an RxJS subscription, it will be thrown on a separate call stack, meaning it is asynchronously thrown. Difficult word. Therefore, what we can do to overcome this hurdle is passing a done callback to the test function. And by calling this test function, we are manually saying when this test is done. And as we now see, when we're having the same pattern as before, but after our expectation called the done method, we are now getting the falsy test, which proves that our test used to work before. If we now replace it back with true, everything's fine and we're good to go. Long story short, use the done callback in any situation when you're testing RxJS. It just makes your test a lot more resilient, and you can guarantee that it's working as you expect. And on top of that, this done callback is supported by a lot of testing frameworks. So you should be pretty good with that testing approach. I can now hear some of you saying like, okay, testing off is quite easy, right? Testing off is quite easy. So what if my observable has multiple emissions, like interval, for example? Interval emits after every X seconds or milliseconds. So how would I test something like that that emits multiple values over a period of time? Well, let's take a look at that. And for demonstration purposes, we're using from with an array, which will then spreads the array synchronously, but spreads it. So in this scenario, we have an observable that emits first 0, 1, 2, and then 3 consecutively. How would a test for that look like? What I like to do in situations like that is creating an array where we store the values, and in the subscribe block, we push the values to our received values, and afterwards we have an expectation. You might have noticed now something that after the subscribe, have the expect block. This just works because from is emitting synchronously. So how would that look in an asynchronous example? How can we handle that? In an asynchronous example like interval, for example, what I would do there is basically applying the same mechanism. So having subscribed to the next channel and pushing the values in the array, but in the complete callback, when we know, okay, all the value emissions are done now, we are doing our expectations and then afterwards call done. Problem with that is that this logic to work properly assumes that a complete signal has happened. And Interval, for example, does not complete by default. So how would you handle situations like that where you have an observable that does not complete? My personal recommendation here is use a completion operator. It's not, I agree with that, it's not ideal to use another operator for your testing purposes, but it will make your life a lot easier and you focus on the necessary parts for your test. And on the other hand, when we're talking about unit testing, you can assume that the library you're using, RxJS in that scenario, should work as expected. Therefore, you technically can leverage operators from that. This is, from my perspective, a little bit of a gray area, but this is the way I deal with that problem. So I would usually use a completion operator like take until, first, something like that to just mark your observable as completed, and then you can apply the same pattern as shown before. Sorry for that. One thing I want to recommend here is that you check out Observer Spy. It's an amazing library created by Shai Resniak, and it's basically wrapping this pattern and making it a little bit more accessible for you. And it's also tracking errors and complete signal and stuff like that, and makes it a little bit easier to use. So if you're familiar with the basic pattern, check this definitely out. It's a great library. Even though this is a remote talk, I can exactly hear people now saying like, okay, all those patterns were nice and easy, but in real world, that's not that easy, right? Talks are great for showing easy things in an approachable manner, but this is not real world. Fair. I give you that point. So let's talk about a real world example. And this is slightly adapted, but extracted from a code base I'm working on. So what we're having here is an observable that takes care of an authentication mechanism. In our situation, it's opening a pop-up, and we actually had a lot of brittleness there, which means that it sometimes failed and sometimes not for whatever reason. So what we implemented is a retry mechanism where we said like, okay, retry at maximum 2 times for certain errors, and everything else ignore or go ahead, depending on that. On top of that, we're also using share replay to prevent concurrency. So if we would have multiple subscribers to that while a login process is going on, we would have concurrency issues. With share replay, we can mitigate that. How would this authenticate method then look that is used here? So for testing purposes, I mocked this a little bit with having a raise operator and from event where I'm saying like, okay, when I'm getting a login event, I just map this to true. When I get an error event, I map this to a certain error. So this way I can simulate my API for the purpose of this talk. And the public API for this observable to be accessible, as this was wrapped in a library, I wrapped this in a method just to make it a little bit more accessible. It can also easier restrict it or extend it later on. So what I want to tell you is, even though this example was a lot more complicated already, the test for that looks exactly like the stuff I showed you before. So what do we have here? We create an instance of our authentication class. We're subscribing to the login with pop-up method and doing our expectation with the done callback. The only thing we have to consider here is that we have to dispatch the event to trigger our observable after we subscribe to that. As we are having a cold observable here, this is the only thing you have to keep in mind working with observables and testing. First subscribe, then act, if we're talking about AAA tests, for example. We can even test the negative scenario here, meaning, okay, we're expecting an error. And for that to work, I had to dispatch the error twice, because then with the retry, when first after 2 errors, the error was passed through to the subscriber. Therefore, I'm dispatching the error event twice, and then I'm expecting an error to be emitted on my observable. Works exactly the same. Subscribe to it, done callback, and you're done. So testing seems to work fine. What about mocking? An integral part of testing is also mocking, as you might not necessarily want to test your observable, but it's interacting with your unit that you're testing. So for mocking, I personally always apply a 6-step mocking strategy. So what we have first is, in any situation when I want to mock something, I start with the never constant provided by RxJS. The never constant is an observable that neither emits something nor completes. Having that said, it does not trigger anything in your code. So if you're using never, none of the code that is dependent on this observable will be executed. But on the other hand, you don't run into a problem where you're saying like, okay, something is not initialized, cannot call pipe of undefined, stuff like that is mitigated by just using a empty observable, to call it like that. So this is the first step. If I just want my code to run, but I don't care about the observable. Next step is using off with a single object. With using off, I have a synchronous observable that emits some constant value. Having something like that in place helps me creating expectations and stuff like that. So this is like the most common, most basic usage, how you can mark an observable of an static value. If I want my observable to be asynchronous, I personally apply a pattern where I call off and then delay. Technically, you can also, in this example, I use delay with 1 second. Technically, you can also just use 0. It will also be asynchronous. That's not the point here. The point is the combination of off, or the off operator, with delay makes your single expected value asynchronously emitted to see if your observables and your code works in an asynchronous manner too. After that, when we now have single values and asynchronous value, now we come to synchronous multiple values. What I use for that is from. From with an array will be spreaded, so we will have 3 emissions, an example here, where we would have like first 1 and then 2 and then 3 emitted. The same goes for asynchronous, but what I personally rather do there is using interval. It creates a tick every X second. We already saw the marble diagram. That's usually how I deal with situations like that. You might also want to apply something like map to create it or to map it to a certain object, something like that. But the basic part is creating the observable according to your needs or to your test scenario, whether you want to test multiple, single values, asynchronous values, etc. And we now have 5 steps already. And the last step is, and what I usually do when I want the full flexibility of the code, or for my mock object, is I use a subject. And then within my test, I can define the behavior that I want for this observable at what time. And then you can decide whether it emits asynchronous, synchronous, however you want it to work. And technically, you can even leverage the different subject types for that, also depending on the code you're using. But this is a 6-step mocking strategy. Start with never, use off with delay, from interval, and then the subject. And those are the patterns that I apply on a daily basis when I work as a consultant. And I didn't have a situation where I couldn't apply one of those strategies. So having that said, we now have testing and mocking already covered quite well. We're making good progress here. So let's talk about marble testing. A talk about RxJS testing wouldn't be complete without having talked about marble testing. So marble test is a visual way for us to represent the behavior of an observable. And marble diagrams itself are amazing, right? They're on the docs. Every blog post that is about RxJS usually leverages marble diagrams to some extent. And therefore, the idea a couple of years came up, like, why don't we use marble diagrams for testing purposes? And in our situation, we're actually talking about ASCII marble diagrams. And I'm not talking about this level of ASCII art, but more like how to represent a marble diagram as an ASCII art. So for this, you have to learn a little bit of a new syntax. So let me guide you through this real quick. So you have the normal dash, which represents 1 virtual milliseconds. Virtual means that this is scheduled virtually. You can also combine this with values and milliseconds, seconds, minutes, and stuff like that to make it a little bit more flexible if you have an observable that takes ages. You also have the situation like from, for example, emits all the values synchronously, so you want to group certain values. And you can do this with parentheses. In the ASCII art, you use A, B, C, D to represent value emissions. So you can use any alphanumeric character to represent a certain value, and how this works later on, we will see an example. The hashtag, or however you want to call it, is an error emission, and the pipe represents a complete emission. Those are basically the keys that you need for marble testing. So how would an ASCII marble diagram for this marble diagram look like? So we're having the off operator that emits true, meaning it's a synchronous emission of the true value. And how this would look like is we're having the parenthesis because off completes immediately. So the emission and the complete signal happens at the same time. And then because we're just supporting alphanumerical characters in the marble diagram, we're saying later on, okay, we want to replace the character A with the value true. This is how the ASCII marble diagram for off would work. Interval is a little bit more complex, and this is also where it starts to get tricky. So how would that look like? ASCII marble diagrams technically start at a 0 second or at a 0 millisecond. Therefore, the first emissions happens after 1000 milliseconds, from 0 to 999 milliseconds. Then on the 1000th milliseconds, there's the first value emission, which is later on replaced with the value 0. And then we have always 999 milliseconds to wait to the next second, and so on and so forth. And this is also where it starts to get complicated in my point of view, because when you're using RxJS and particularly the interval operator, you don't need to know those level of details. For using marble testing, you will. But let's talk about the benefits later on a little bit more. How would such a test now look like? Because now we just talked about marble diagrams and ASCII marble diagrams. How would a test with those look like? So first, you create an instance of the test scheduler. And usually in a proper test suite, you would create a test scheduler before each block or something like that. Enough to have it all on a slide, I put it here in the test. What you have to pass actually is a method to do a deep comparison. And this is a little bit depending on your assertion library. So whether you use Jest, Jasmine, Chai, those deep equal comparisons might look a little bit different. I was using Jest here, so therefore I used 2 equal. And everything then that happens within this test scheduler run method is virtually scheduled. So even though you're using interval and stuff like that, even though it should be asynchronous, it isn't. It's virtually scheduled. And the test scheduler exposes a couple of helper methods. For our certain use case here, we just had to work with the expect observable. So expect observable does what it says. It expects an observable to be an ASCII marble diagram. There's also something about expect subscription, expect unsubscription, and stuff like that. So it provides helper methods to test RxJS use cases. And what we then have is that we have one stream that we want to test. In our case, forever stream or called forever stream. And here it's an interval with I use take 4 because also for marble tests, the observable that is to test has to complete. Otherwise, you will run into an error. So what we then hear is having the marble diagram I showed a second before with the weird edge case of 1000 milliseconds. And also what you have to consider when using take is that it will emit the last signal and in the same tick complete. So the emission and the complete signal happen in the same at the same time. So this is the ASCII representation of the observable before. So how would this then look when you have the expectation? Instead of what you usually do, expect something to equal, you now say expect observable, your test observable to be the marble diagram, the ASCII marble diagram, the string, and then you can pass an object, which is used then for the value replacing. So far I tried to be very objective on marble testing, and for the RxJS library, it's a great tool, but for business application, I share a little bit of a different opinion. But let's first talk about the benefits. And what I want to highlight here is that marble testing is extremely powerful. You can test edge cases, you can test concurrency issues, you have very high level of detail that you can test. It also helps you in understanding RxJS a lot better, just because by representing the observable with this ASCII marble diagram, you will learn a lot how operators work and behave. So this is definitely a benefit that I want to mention here. On the other hand, it's also visualizing your observables. So it might help you in understanding how your code works and when you're used to that level of syntax, it might be easy for you to maintain that. On the other hand, you first have to learn this new syntax, and it's just for this very use case. An ASCII marble diagram will very likely not be in your code, so there's nothing else you can do with this skill that you just learned. It also, on the one hand, it helps you to understand RxJS. On the other hand, it requires a lot of knowledge about RxJS to make it work reliably and not just do a comparison. Okay, what is wrong, and test and change your expectation accordingly. That's not a test, right? So you want to test the stuff that you understood as well. So this is definitely a drawback from my point of view, as you have to learn a lot about RxJS. And if you're not used to that syntax, and if you're in general not feeling super familiar with RxJS, it's extremely hard to maintain. The marble diagrams can become unreadable very quickly, and it's a level of complexity that for business application, in my point of view, you might not want to deal with. And the last thing is, from my point of view, you're very likely testing RxJS internals. And that's why I mentioned before, I don't consider marble testing the proper tool for business application. Business application, you're process driven. You want to test that certain things act accordingly to your expectation. And this does not necessarily mean you want to test that when you're using interval, it emits after 1 second and not after 1 second and 1 millisecond. This is a level of detail, and therefore, from my perspective, the wrong abstraction layer for testing business applications. If you're testing operators or very complex RxJS code, this is, from my point of view, the perfect tool for that, just because it gives you those extremely powerful tools that you want to use. For business application, not my tool of choice. There's nothing I can add to this slide. My personal opinion, I'm a consultant since more than 4 years now. I had 2 situations so far where I said marble testing is the right tool for this use case. And besides that, I always went through with the patterns I showed you before and never had an issue with them. Let's give a quick summary. So for a summary, I created this short diagram. So from my point of view, if you're if you're having custom operators created, or you're having very complex RxJS code, and this might, for example, be an NGRX effect. If you have situations like that, marble testing might be the right tool of choice for you in this situation. Other than that, you should ask yourself, do I want to test multiple or single values? If you want to test multiple values, go with the array method I showed you before, or use observers by. Technically, observers by also support the single value use case. Might be a little bit over the top, but if you're having an observable that just emits once, feel free to use the done callback. You should be pretty quick in writing that test. Having that said, I want to thank you everyone for coming to my talk and listening to me. I really appreciate this conference and hope everyone is staying safe in these crazy times. Have a nice day.